I think engineering teams need to be thinking about how they can get out of verifying every line of code because otherwise they're going to be completely buried in
Right.
that and will absolutely be the bottleneck. And
Hello, folks, and welcome to HangarDX podcast. This is a podcast focused around developer experience and how engineering teams solve productivity challenges at scale. I'm your host, Ankit, co-founder of Aviator. At Aviator, we are building AI coding verification platform that helps provide better guardrails and reduce AI slop. Today, with us, we have Jade. Jade joining in, bringing in a lot of experience of engineering and engineering leadership. Yeah, Jade Rubick was previously VP of Engineering at New Relic and Gremlin, and has been driving a lot of like engineering consulting as well as like giving a lot of coaching to engineering leaders. Obviously, Jade writes a weekly newsletter you might be familiar with called Engineering Leadership, and also runs a podcast. So, Jade, I'm really excited to have you here. Do you want to also introduce yourself? Anything that I missed?
well, that was a wonderful introduction. I'm delighted to be here. I've really, really appreciated the content you're putting out there. I think it's really a lot of kind of cutting edge information. And the communities you are creating are really exceptional. So I'm happy to be a part of them. Um, my, I think you introduced me pretty well. I guess the thing I would add to it is the last 6 years I've been working as a consultant. And so a lot of what I'm doing is working across a lot of different startups, both directly in the startups. So I often will take on engineering leadership on an interim basis and also as an advisor or coach. And so what has been useful about that for me is that it's helped give me experience across a lot of different startups. The other kind of caveat I would give is that most of my clients and most of my experience is in small and medium-sized startups. And so the applicability of my experience may be less relevant in larger companies, but I do also have clients in larger companies. So I have a little bit of a smattering of everything.
Amazing. All right, so let's dive straight into the topic. I would want to talk to you a lot about like organization structure, especially as AI is taking the center stage. A lot of people have questions. Do the org structures that we had pre-AI still are relevant? Do we need to kind of like change anything? I don't know if you saw the news, but Meta is also kind of like trying to reduce team sizes. Some folks are talking about like, EMs, TLs, PM, all of those things colliding as well. So maybe kind of like just start with, where do you see sort of any change that is happening today? Have you seen patterns of organizations changing their org structure? And like, are there any patterns emerging?
It's a wonderful question. I guess I'd preface this by saying that it seems to me like we're in an age of experimentation. So there's a lot of change going on, and sometimes it can be kind of hard to discern what's actually going to happen because you see so many different things happening at the same time. I'll start by maybe saying a little of what I've been observing, and then maybe we can talk a little bit about where this might be going. I'm seeing a lot of friction around some of our traditional role definition. So I see a lot of places where product managers, for example, are starting to produce completed and very polished looking, engineering looking artifacts. And this is causing some of the like traditional ways that we've divided up these roles to feel kind of arbitrary. And it's often actually putting a lot of stress on the engineering teams because the incentives on them are kind of terrible. It's like you seem to be moving slow if you're like making sure all the quality and operational practices and code quality and all these things are good. And yet if you ignore those things, you're the one ultimately on the hook for all the failures that will come later. And so I think a lot of engineering teams are kind of feeling a squeeze there where the expectations have risen a lot, but the role definition is still hasn't really changed. I'm also seeing some companies where non-engineers are committing code and where that is kind of an explicit goal is to encourage that more. I'm seeing some pressure on design. I see also designers like wanting to be more involved in code. And so I guess what I would say I'm seeing as a kind of pattern there is that the role definition seems to be blurring a little bit. I mean, there's a lot of like engineering practices that are probably more relevant than they've ever been, but the kind of the comfort we've had about, oh, you just organize like this, it doesn't seem to quite work the way it used to.
Interesting.
I guess one other observation is that I'm also seeing there was a longstanding debate in engineering leadership circles about whether or not engineering managers should code. And I'm finding that is sort of disappearing. Like while there are still remain some of the same power dynamics and other concerns you may be concerned about, I'm seeing engineering managers and engineering leaders much more willing to and kind of feeling a need to engage in the code. So, for better or for worse, I see a lot of leaders kind of returning to coding and seeing AI as a route to doing that. So it seems to me like that kind of debate has been resolved in favor of, yes, engineering managers should code. And that's a pretty big change.
I feel like there's like two sides of pressure, right? Like one is kind of like coming from the leadership. It's like, okay, I've even seen roles open of like, hands-on engineering director, right? Where they're like director level expecting to write code.
Yeah.
Versus seems like there's a little bit of like maybe even turf war, if I were to use that term, even at like, PM levels, designer levels, even, IC level engineers, where everyone is trying to contribute, everyone is now capable of it. I think one aspect which I feel has changed is engineering used to be very black and white, which is like, can you write code or can you not write code? That thing has now disappeared. So everyone can contribute to some degree. So I think that is creating some of these shifts as well. Where do you think, kind of like, as even middle managers and sort of like, or maybe even kind of like folks who are thinking about organization structure from the top, how should they approach, uh, you know, building, maintaining, and growing their orgs?
I think, first of all, it is appropriate for a director, for example, to be engaging in coding because I think familiarity with this new paradigm of agent development is kind of essential for our whole field. And so I would say VPs should be doing that, and really everybody should be. You have to do that with a certain amount of humility. You're going to have a different experience of using these tools than people that are coding every day. And you're probably, for example, going to be using a lot simpler projects and are going to be a lot more successful at it. And you're going to be, because you're doing simpler things. And I think there's a bias there that is leading a lot of leaders to actually have more confidence in these tools than they're actually able to fulfill sometimes, which may be appropriate in terms of like directionally where these things are going. But some of the people that are working in the corner cases that are really hard to use AI agents, or where it's harder to set up the context for it, or you may develop a feeling for things that is different than a lot of the people you're leading. I think the turf wars is really interesting because I went through this experience before AI really took off when I was working at a company where we implemented the single-threaded owner model from Amazon. And what was interesting about that is kind of like a leadership experiment was essentially we collapsed the separate hierarchies of engineering, product, and design into one hierarchy. And there were all sorts of really interesting challenges with that. One of the biggest ones was everybody had an identity built around being, I'm an engineer, or I'm a product manager, or I'm a designer. And that really worked very counter to collapsing all these things together. And I think we're kind of seeing something similar with these turf wars. Like if you have if you have a product leader and an engineering leader, and if you could be more effective if you collapsed those hierarchies and worked together more closely, those two people aren't incentivized to do that most of the time. And so you'll probably pursue some other strategy that mimics it, but it may not be the ideal thing. And so I guess I would really encourage leaders nowadays to be aware of that as a constraint, like how our identities factor into how we work and organize ourselves, but also keep in mind that that may be a bit of a shortcoming and that there might be better ways to work together than what our historical roles have been.
Very interesting. So, just kind of like double clicking a little bit on this, I feel ownership is an interesting topic in itself, right? Generally, the way I think about it is engineering leaders, they own sort of like, the architecture, the kind of like the code quality, the processes around software delivery. And then the product side, sort of like maybe PMs, at least historically, own sort of like, the products and the capabilities and the features. So in your model, when you think about sort of like a single owner, one, is it like still applicable in the world? I feel like it might be more applicable today than before. And two is kind of like, how does that balance play out?
I would probably start off by saying a lot of this is unclear and may shift. If our thinking on this hasn't changed in 6 months, that would surprise me. When I'm looking at it right now, I guess I read a piece recently by Keith Morris, and he talked about how I think this was published on the Martin Fowler blog, and he was basically saying that we're going from a first phase of us writing code ourselves to humans being in the loop to he is kind of seeing this third step of humans on the loop, and that is essentially where we're trying to create systems that produce the results that we are looking for, and we're much more like maintaining the system that is producing those results. And so it's a little bit, it's a much more automation heavy and much more kind of like overseeing a system and looking for automatic verification and making kind of overseeing a bunch of like human and automated processes to produce good outcomes. And so it's a bit more like we're making factories than that we're handcrafting things.
Products, right?
And so when I think about how we work together as a group of humans to do that, I think there probably is going to be a set of engineering specialists that are very deep on that type of engineering. And I don't really know the best term for that, but for some reason, the term I've been using is like harness engineering, very much like you're creating this harness or this and you're measuring the errors and the quality and the evals and all these things like these security runs and linters and like code duplication scanners and all these things. Whenever something is getting through that is not high quality, you're kind of like improving the system to automate that. But I think in front of that, there's this whole sort of like what I would call product engineering and product development. And I think there's a separate set, I don't know if it's a separate set of people, but there's a separate kind of skill set of like, talking to customers and a lot of the traditional product role things and also product engineering role things. And some of those roles to me seem like they're getting blurred quite a bit. Mm-hmm. But I can imagine having like on a team of people, some of the people engaged in that and some of the harness engineering maybe on that team could be separated out onto other teams. But I guess what I would expect to see is both centralized and decentralized versions of that. Like, if I think about like the role of design right now, I'm not a designer. I've led design, but I haven't. I'm not a deep specialist in that area. But I would expect there would be like in medium-sized companies, there might be like a couple people kind of overseeing a design system that is actually embedded into all of your processes, and then maybe like some design focused people that are actually doing kind of engineering work throughout and making sure that your visual language and your usability and all of those things are kind of like evaluated, and the output of that is what your company is looking for. And I would expect kind of a similar kind of centralized version of some things along with decentralized, so embedded in a lot of teams.
Okay. So I know you kind of like already mentioned this briefly in this conversation, but I would like to maybe also double click on your concept of automated verification engineer. I feel like this is also closer to a lot of things that Aviator is working on. Maybe you can, like folks who have not read this blog, maybe you can kind of like at least give your high level hypothesis on that, kind of like where things are going with this. I don't know whether this is the same Martin Fowler bug, but there was also a mention in one of the blogs from Martin Fowler, which is around how more engineers are going to spend time building verification and guardrails than actually writing code. So yeah, maybe you can kind of like at least give an overview of that first.
Yeah, so this was a blog post that I wrote, and it was kind of in reaction to I was working at a startup helping them hire an engineering leader. And during that time, I was working with one of their founding engineers, very bright fellow. And he said, well, kind of before we were interviewing these engineering leaders, he said, any person that says that QA should exist is an automatic no hire. I I had a kind of mixed reaction to this founding engineer. I thought his position seemed a bit extreme, but there were some parts to that that I actually really understood where that was coming from. And in the past, I had surveyed my peers, actually gone out to 10 different people, asked them what they thought about the role of QA in a specifically startup environment. And pretty uniformly, what I got back from people was that QA, the way that QA and engineering worked together typically was not very effective. And most of them said that with some exceptions that they would not actually use. I guess I want to kind of I have worked with some really exceptional QA engineers. I've seen the value of QA, and so there's a part of me that kind of felt a little weird about that. And so I guess one thing I want to just be very clear about is that I'm talking about QA as a downstream process from engineering.
Mm-hmm.
That sort of handoff, I think, is where what is typically the most problematic portion of it. And so I was working with a QA leader, and he asked me, like, what would you advise for QA nowadays with AI being around? And so I started to think about, like, the value of verification nowadays is automated verification is like such an enabler of automation and such an enabler of velocity now in a way that it is just so much higher leverage than it was even a year ago. Because AI agents, if they can get quick feedback on things that they're breaking or things that they're like making worse, it's like gold. They can iterate. And these agents often do not produce the best results immediately. It's kind of through
Iterations,
like an incremental process that they're effective. They can't like, you can't give them all the heuristics that they need to keep in mind and get a perfect result. It's much more like you give them a set of constraints that they bash their heads against until they come up with something that works really well. Thinking about that, I was like, well, I think it might be a useful experiment to kind of redefine the QA role around automatic verification, and even like moving the a lot of kind of redefining the way that you work with engineering to be much more in line with the teams. And I also kind of reiterated some other practices that I had generally found useful for getting QA and engineering to work more effectively together, namely shifting QA to work more in line with engineering. Ideally, I could imagine an automated verification engineer involved much more in the kind of management of the verification pipeline, making sure that the fastest tests execute most directly with the developer, like as they're working, and things that take a little bit longer, kind of sequencing that out, but really like measuring yourself by how quickly you can give yourself feedback.
So one of the key challenges I've noticed, at least for the friction between engineering and QA, is who owns the responsibility of actually shipping good quality software, right? I think when there is a QA, there is sort of like almost like a trust from engineering is like, okay, now testing is not my responsibility. It is QA's responsibility. I think this also mattered more in the world where there wasn't really like cloud software development, which means is like, shipping software, shipping fixes would take a long time, right? Like I used to back in the days work at Adobe. We would ship software in CDs, right? And when you're doing that, like you can't really risk having poor quality, right? And more when we moved into the world of cloud, this became less relevant. I think now, obviously, because of AI, I feel this is now again becoming more relevant, largely because the volume of code being shipped and kind of like the capabilities of human to continue reading line by line, those things are changing the game entirely.
Yeah. Yeah, I mean, I think engineering teams need to be thinking about how they can get out of verifying every line of code because otherwise they're going to be completely buried in
Right.
that and will absolutely be the bottleneck. And one thing I've been kind of thinking about is I think it's a good goal maybe for an engineering team to ship a certain percent of your commits to production without human verification. And, maybe you start with 1%. What would it take to get some portion of your commits to be able to go out to production without any like human verification? I think it's analogous to CI/CD, where CI/CD is like a set of practices where we kind of like the thinking was, what are the set of practices we need in order to safely ship something to production as soon as it's approved? And we need kind of a similar set of practices and tools around verifying code. And there's going to be some things that always need to be verified, probably. And there's going to be some things that are probably very safe to ship to production. And how do we whitelist those, or how do we how do we allow list those? How do we make those? How do we separate out risk?
Yeah.
Those sorts of things are going to be, I think, increasingly important.
Yeah. I know I can kind of like go on for this forever because in some ways, even with human reviewing the code, there is no guarantee that this is going to not break in production. So it's always about reducing the risk versus completely de-risking
Yeah.
a change. Because if we have to, then obviously everything will slow down significantly. And so again, instead of me talking about this, let's talk about your concept of verification engineer. So from that blog, what was your definition of this verification engineer? Like what will they be actually doing on a day to day? And how do they actually how does an organization even hire this person or kind of like grow this person internally?
Yeah, so I'll preface this by saying this is basically an experiment. I think that it probably exists in the wild, but there's probably a lot of forms of this that could work, and probably some things to be learned about what won't work. The way I described this is, first of all, I think it's important for QA to work within teams if possible, because I think having QA as a downstream process is harmful to engineering. I think engineers don't think enough about their own quality when QA is a downstream process. And so QA, I guess I was thinking of it as being kind of somewhat similar to like an SRE on your team, where the SRE is responsible for, they're like an expert in reliability and operational practices, but they are not the only person on the team that's responsible for that. Actually, the team is responsible for your operations and everybody's on call. And I think there's something kind of similar potentially with an automated verification engineer where they are the people that are the experts in testing. They know how to make a test plan. They could probably do a better job of that than anybody on the team. And yet they're not the person that is doing all of the testing. The whole team is engaged in testing and verification. They may do more like exploratory testing, or they may do some of the hardest things to test. They may have a lot of like domain knowledge around how to do that. But ideally, the whole team views that as their collective responsibility, with that expert being the person that is more focused on that than they are. One of the things I was thinking about with the automated verification engineer is that I think QA often gets in trouble because it doesn't own its own pipelines as much as I think it sometimes can. And I think it might be beneficial for an automated verification engineer to be actively shaping their own kind of pipelines of like what tests are run where, and maybe a little bit more collaboration between that role and some traditional like developer experience roles.
Very interesting. It sounds a little bit similar to how the roles of test engineers, test infrastructure engineers have grown, right? It's sort of like,
Mhm.
where those test infrastructure engineers are responsible for building the infra, like kind of like the way you were talking about factories. And then maybe every engineer who are like product engineers as well are responsible for like in some ways having some collaboration for preparing plans, like test plans, maybe, or sort of like actually what feeds into these test infrastructures.
Yeah. Yeah, I think so.
All right. So maybe if you think about like, evaluating engineering impact, like, engineering productivity, measuring engineering productivity has always been on top of mind for engineering leaders for, I would say, at least 20 years, if not more.
Yeah.
How is that changing with AI, right? Like, if a lot of code is now produced by AI, are we still measuring kind of like the same ways? I know I spoke with some folks recently about even the challenges around maintaining flow states and context switching, which used to be big factors in developer experience, which are now taken backseat in some ways, right? Like everyone is running 20 agents. So, how are you seeing any evolution, if any, for measuring the engineering productivity?
Well, this has always been a very fraught topic. I see a lot of attempts to measure productivity. And I guess my favorite way to measure productivity is to look at outcomes. And the way I have generally what I like to look at is like how much value have we delivered over time. And if our use of AI tooling is accelerating like we're delivering a lot more value over time, then it's working. And if not, then we may be pushing more PRs or whatever. And maybe that's better in some ways that are hard to, we're delivering more incrementally or whatever.
Mhm.
But what really counts is how much value we're delivering. And so the way I typically like to measure that is everything we ship, we score by customer impact and you add it up. And what's nice about that is you can do it retroactively. So you can look at your last year of delivery and then you can go forward. And if you're delivering more value, then that's what you want. And if you're not, then it's all of your perceived productivity gains maybe not actually doing as much as you think.
Interesting. Okay. So I know we are coming close to time. So let's try to kind of like maybe have you give some thoughts on forward looking, which is what are your sort of like predictions that you're willing to be wrong about for 2027?
Great question. Predictions I'm willing to be wrong about. I think the cost for tokens is going to go up for producing the same output is going to go up about 10 times in the next
Interesting. Okay.
year, 18 months. And I think that's probably fine.
Do you think it's a matter of unit economics or is there other reasons for this?
Well, I think this is actually a little hard to. The reason I said this is because I'm willing to be wrong about it. There is a lot of competition in the
Right.
space. And so there's reason to think that the competition and the amount of money invested will keep this going for a lot longer. But like what is happening right now, it seems pretty unsustainable.
Right.
And, maybe there's going to be cheap or free versions of this that keep the unit economics really low. And I would be willing to be wrong about that. But I also think that there is a willingness to pay a lot more than we're currently paying if we start getting better at some of these practices. And if that's the case, I would expect the cost to go up a lot.
Very interesting.
Go ahead.
Now, I was just going to say on the other side of this, like a second complementary prediction for this is people might start using more open source models and hosting these things themselves.
Yes.
I think I think even very recently, from what I heard, the DeepSeek's models, at least like SWE benchmarks, are comparable, if not better, than existing sodas, which means that especially like only for coding cases more specifically, because that's what's driving a lot of volumes, at least today. If that problem can be solved with open source models, I think organizations, especially the large ones, might start looking into hosting it themselves. Then the question becomes is like how defensible are the harnesses?
Yeah. I totally agree with that. And I'm definitely seeing that. My rule of thumb is it lags about 6 months, and 6 months is significant, but also not that significant. And I think that's totally right. Okay. I'll give you a couple of like maybe things that I'm willing to be wrong about, but
All
things
right,
that
let's do it.
I think companies that have written cultures will see disproportionate gains over those that don't.
Interesting.
Because the more your company is using written artifacts, the easier you are going to be able to set up a lot of your business processes to be automated. I think that weirdly, I think like migration projects and a lot of like technical debt projects, because the cost is dropping for a lot of these things, they're actually lower leverage than they used to be. They're easier to do than they have ever been, but they're getting easier over time.
Okay.
And so there's a way in which like it might make sense to defer some of these migration projects, because if it's twice as cheap as in a year, is it worth doing now?
Interesting.
It's like deflation. Um,
That's a very interesting perspective, right? I think, yes, like code is getting ephemeral, but like you don't need to tackle all the problems today because it'll get easier and easier.
and then maybe another prediction. I think I just read a wonderful blog post by Jim Shore, and he was talking about some of the second order effects of coding agents. And his basic thesis was that if you're getting twice as productive, your maintenance costs have to be at least halved. And I think that we're going to see a lot of organizations that are not keeping up with that. Historically, in DevX, what you're fighting is the complexity of a company. You're trying to bend the curve against the rising complexity of the company and keep your productivity from getting worse over time.
Mhm.
I think we're going to see the kind of this curve an awareness of this curve with AI development in a way that we haven't in the past,
Interesting.
because we're going to start hitting large code bases with tons of AI generated code. And if you're not investing a certain amount of that productivity gain back in higher quality, you're going to start having really big problems.
Amazing. Okay, I think this is a great note to end this. Jade, thank you so much. This was a really fun, amazing conversation. And thank you, everyone who was listening. If you're interested in developer experience or work in AI and platform engineering, join us at HangarDX. We also run virtual sessions and run podcasts. Again, Jade, this is amazing. It was really fun. Pleasure conversation.
It's been a total pleasure. And just to kind of plus one your own pitch, like I think the community and the things being put on by you guys is just really top notch. So
Amazing.
yeah.
Awesome. Thank you, Jade.
Thank you. Take
All
care.
right.